All right, today we're going to look at section 3.3, which is division. Mainly we're going to concentrate on synthetic division, and we're going to divide our polynomials using the method called synthetic division. So when we do this, it is the first thing we want to look at is just like our what we call the division algorithm. So when you were in elementary school and you did long division, you had just dividing like 38 by 7, you had what we called the remainder. So we have a lot of things in here with terminology. So what we're going to do is we're going to do this with polynomials. So we're going to have x's in it, not just numbers. And our answers will have to be written in one of these two forms. So just so you understand, notice down here that the dividend, that's this part up here, that is what our p of x is when you're looking at notation. Our d of x is our divisor right here. Our quotient is our q of x. And then our remainder up here is our r of x. So you're going to be asked to write your answers in one of these two forms. You'll have to pay attention to which one it's asking so that you make sure you get it right. So the divisor and the dividend will always be given to us. What we're going to do is use synthetic division to get the quotient and the remainder. So synthetic division is just going to be a shortcut of long division. Instead of writing everything out really long, we are going to use long division. We can only do it if our divisor is a binomial though, which in our case today, all of those will be true. So I'm just going to do some examples. Depending on teachers you've had, if you've seen this, they do it a little bit different ways. But what I like to do is I like to start by we're just kind of going to make a little box, or half of a box, I should say. And we need to figure out a number that's going to go on the outside and numbers on the inside. So for the outside number, you're going to take your divisor right here. So this is our d of x, and we're going to set it equal to 0. So x plus 3 equals 0. X equals -3. What we get right here is the number we're going to put on the outside of our box. On the inside, we are going to put our numbers that are the coefficients of our p of x right here, of our dividend. So notice we have x to the 4th. It has a 1 in front of it. Notice I skip. I go from 4 to 2. We can't skip, so I'm missing an x cubed term. We can't do that. Since we're missing it, we'll put a 0 in here. Then -10, -2, and r4. So there we've just set the problem up. So next what we need to do is work the problem. To do that, we're first going to bring down whatever this first number is. Ours is a 1. Then you're going to multiply the 1 times the -3 and put it in the box. And then in the box, we're going to add 0 plus -3 is -3. Then you're going to multiply -3 and -3, which is 9. Add in the box -1, multiply again would give me 4, or whoops, would not give me 4, would give me +3. So I get 1 again, multiply again, -3, and I get 1 again. So it's just a whole moving on, multiply, add, and then we're done. So this number here that we got at the very end, this is our remainder. So this would be our r of x. Notice how we want our answer, q of x plus r of x over d of x. So now I have my r of x, I know my d of x. So we need to find our q of x. So to get our q of x, we're going to use the numbers that we just found down here, minus our remainder. So you start, you have a 1, we have to add an x to it. You have to figure out the exponent. The exponent's 1 less than what we started with. Since I started with x to the 4th, this would be x cubed. Then -3x squared, you just keep going down. -1x, and then +1. Your last one will never have a number with it. So there's our q of x. So if we write it in our form that it wants up here, it wants our q of x, so x cubed minus 3x squared minus x plus 1, and then it wants plus, so plus our remainder, which is 1, over our divisor of x plus 3. This would be our final answer. Okay, so let's do another one of the exact same thing with different numbers. So we still want the same form right here. We're still given our problem up here. We're going to start our L. I have x minus 5, set it equal to 0. So x equals 5 is what goes on the outside. Use this to figure out our inside. So I have a 2x to the 4th. I'm missing an x cubed, so put 0. 5x squared. I'm missing an x term, so I need another 0, and then -3. So again, bring down our 2. Multiply here, 10, add inside 10, multiply again, 50, add 55, we're going to get some big numbers here. Multiply 275, add again 275, multiply by 5 again, 1375, add in here 1372. So again, remember this last number is our remainder. So for my q of x, we just need to add x's here. So I'm going to have 2x, since I started with a fourth power, it's going to be cubed again, plus 10x squared, plus 55x, plus our 275, and then plus our remainder of 1372 over our dividend of, or a divisor of x minus 5. So synthetic division is the new part. How you write your answer just depends on what it's looking at. So our next example, we're still going to do synthetic division, but notice it's just changing the way we're going to write our answer at the end. So we're going to start the exact same way. So to figure out, this time my d of x is 2x minus 1 equals 0. So if I solve that, I would get x equals 1/2. That's the number that goes on the outside. Inside, I have a 4 for my x squared, negative 3, and then a negative 7. I don't have any zeros this time because I'm not missing any terms. Bring down my 4, multiply 2, add negative 1, multiply negative 1/2, add in here would give me negative 15 over 2. So again, this is my r of x. Okay, this 2x minus 1 is our d of x. So for my q of x, I have my 4. I need to add an x because I started with x squared. This is just going to be x minus 1. So when I write my final answer, d of x is 2x minus 1 times q of x of 4x minus 1 plus my r of x of negative 15 over 2. You could just write that as minus 15 over 2. You don't have to have plus a negative. So you have several of those on your assignment. The next thing we're going to get to is what is called the remainder theorem, and this is just another way to evaluate a polynomial. So if a polynomial p of x is divided by x minus c, then the remainder is our value of p of c. So it's kind of another way to evaluate functions. So in here, if you're given your function, and then it wants us to use the remainder theorem to evaluate p of c, well, c is negative 2, so what I really want to find is p of negative 2. Normally, you would just plug that in. Well, we're going to use synthetic division to get the answer. So if it ever asks you to use the synthetic division or remainder theorem, you need to show me that. When that happens, I know what x is, so I'm just going to put the negative 2 on the outside. Inside, I'm going to have a 3, then a 5, negative 4. I'm missing an x squared term in here, so 0. And then I have 7 and 3. We'll work through synthetic division like just what we've been doing, so bring down our 3. Multiply negative 6, add negative 1, multiply again, add, multiply, add, multiply, all keeps going the same way, multiply. So again, this is my remainder, and the remainder theorem says that that's our answer. So when we get here, p of negative 2 equals 5. So if you plugged in negative 2 and put all that in your calculator, you would get 5. This is just another way to do that. So I have a few of those on your assignment. The next is the factor theorem, and this is just saying we want to check to see if something is a factor. So if c is a 0, then it's a factor. We've also talked about that before. So what we're going to do, so when you're doing this, if you go through synthetic division and you get a remainder of 0, then it is a factor. These are simply going to be yes/no questions on your assignment. So when you're given, use the factor theorem to show if x minus c is a factor of p of x for the given value of c. I just want to know, is this a 0? So to do that, we'll do our synthetic division. Negative 2 would go on the outside. Our inside is going to be our 3, 2, negative 9, and negative 18. I don't have any zeros this time. So maybe pause, work through synthetic division, see what you get. Bring down the 3, multiply, add, multiply, add, multiply, add again. So this is my remainder. To be a 0, that has to be 0. Since I got negative 16, then this is not a 0. Negative 2 is not a 0. To be a 0, I would need to get 0 right there. So just There'll be yes, no questions. The last thing we have is writing a polynomial. Normally it's going to say write a polynomial equation or some type of an equation, so we're going to need a y equals, be given to you in your homework. We know what our zeros are, we just need to write them as linear factors. So think about when we were looking at graphs. If I knew it crossed at -1, when I wrote that in a factor, I wrote x plus 1. If it crossed at 1, it would be x minus 1. And at -4 would be x plus 4. That's all we're doing. You are done right there. You're just writing them in linear factors. Don't need to multiply it out. You can put just that in. So another one of those here. This time I have -3, 0, 1, and 5. So y equals. If I am given a 0, I like to start by just putting an x right there. That's my 0. And then x plus 3, x minus 1, and x minus 5. And that is our 3-3 lesson for the day. Let me know if you have any questions.